Hi there, welcome to my tutorial on the binomial expansion. In a previous tutorial I showed you how to use Pascal's triangle in order to expand a binomial expression. What I'd like to do today is show you another method by which we can expand these types of expressions. That's known as the binomial expansion formula. It's as shown below in the insert here. There are two of them. We're going to look at the first one today. In order to do this though, we need to look at something known as factorials and NCR. So let's see what they actually mean. Well, a factorial is just shown by this little exclamation mark here. And as a practical example, 5 factorial just means 5 times 4 times 3 times 2 times 1, which gives us a total of 120. NCR, shown by the formula underneath in the insert there. The formula is n factorial divided by r factorial multiplied by n minus r factorial. So again, looking at a practical example of that, if we have a look at 5c2 here, what this means is the n is the 5, the r is the 2. So putting that into the formula, we get 5 factorial divided by the r, which is 2 factorial, multiplied by 5 take away 2, which is 3 factorial. So if we work that out, we're going to have 5 times 4 times 3 times 2 times 1, and we're going to divide that by 2 factorial, which is 2 times 1, and multiply that by 3 factorial, which is 3 times 2 times 1. Now simplifying that and cancelling out the 3, the 2 and the 1 terms here, we're just left with 5 times 4, which is 20, and 2 times 1, which is 2, which gives us an answer here of 10. So 5c2 actually gives us 10. Now if we have a look at that in a practical sense, if we've got these letters here, A, B, C, D and E, what 5c2 is really saying is we need to choose a pair of numbers, the letters, 2 letters, out of a total of 5 letters. How many different ways can we do that? How can we group up 2 numbers? How many times can we do that? So if we have a look here, we could do AB, can link A with B. We could also link A with C, A with D, and A with E. If we then move on to the B, we can't link the B with the A because it's already been done here. But we can link our B with C, our B with D, and our B with E. Moving on to the C, we can now only link the C with the D, and the C with the E. And finally the D, we can only now link with the E. So if we count those up, we've got 4, 7, 8, 9, 10 ways of doing that, which obviously compares with the 10 we got when we put the numbers in and used our NCR formula. Now how does that help us though in expanding a binomial expression? Well, if we have a look at 5c3, 5c4, 5c5, we'll get a better idea of what's happening here. What I'd like you to do first of all though is note that 5c2 gave us this number 10. Now if you have a look at Pascal's triangle below, that 10 relates to the 3rd term in the 6th line of Pascal's triangle. Let's have a look at 5c3. Now this can be done on a calculator. There's an NCR button on the calculator. So let's just type this in. Have a look below. If we type in 5, then press our NCR button, then type in 3 and then equals, we're going to get the answer of 10. So 5c3 also equals 10. Note that that's the 4th term in the 6th line of Pascal's triangle. Let's try the next one, 5c4. Type in 5, press your NCR button, and then 4, and you'll see we get the answer of 5. which relates to the fifth term in our sixth line of Pascal's triangle. If we then type in 5C5, type this in, 5, then NCR, then 5, we get the answer 1, which is our last term in the sixth line of Pascal's triangle. So what this NCR is doing is actually giving us our terms in Pascal's triangle. Now, from that, we can develop a formula. Look at the formula below here. NC0 AN B0 plus NC1 AN minus 1 B1. That's very much like what we did with Pascal's triangle. The only difference is we've replaced the letters, the numbers, in Pascal's triangle with the NC0, NC1. Now what I'm going to do is I'm going to use this formula here to expand this expression 2 plus 3x to the power of 6. And we'll do this as an example. Okay, let's have a go then in expanding this expression here, our 2 plus 3x to the 6, using our binomial formula. So first of all, we're going to type in our NC0, which is 6C0. That's going to give us 1. We're going to multiply that by a to the n. A is 2, so it's 2 to the 6. And that's multiplied by b, which is represented by the 3x, to the power of 0. Our next term, we're going to type in 6C1, which is going to generate the number 6. We're going to multiply that by 2 to the n minus 1, which is 2 to the 5. And we're going to multiply that by 3x to the 1. That's our second term. Our third term here, we're going to type in 6C2. That's going to give us an answer of 15. We multiply that by 2 to the n minus 2, which is 2 to the power of 4, multiplied by 3x, and we're going to square it. Note that I'm putting the 3x in brackets so that I make sure I square the whole of the 3x there. And our last term, if we type in here, we've got to type in NC3, so that's 6C3. That gives us an answer of 20. We're going to multiply that by 2 to the 3, and that by 3x to the 3 as well. So there's our 4 terms in our binomial expansion. We are asked to calculate the first 4 terms. If we simplify all these and tidy it up a little bit, multiply all these out, we're going to get 2 to the 6, which actually gives us 64, multiplied by 3x to the 0, which is 1. So our first term becomes 64. We're going to then add that to the answer to 6 times 2 to the 5 times 3x. That gives us 576x. Then we're going to multiply that by our next term here, 15 times 2 to the 4 multiplied by 3x squared. That's going to give us 2140x squared. And then finally, we've got to multiply that by, we've got to add that to our last term, which is 20 times 2 to the power of 3 and 3x cubed, which gives us 4320x cubed. So we've got our first 4 terms in our binomial expansion. Now it is important to note that we can only use this particular formula when n is a positive integer. In the next tutorial I'll show you how to use another formula, the other one shown below, when n perhaps is not a positive integer. It could be negative, it could be a fraction.